Hello everyone, this is Billy. This is part 3 of the 4-part video to create and design the Fusion 360 design for FM crystal radio. On part 3, we'll finish the last bit that is about drilling holes into the baseboard and also laying out the parts on the surface so it will be readily printed. Before we start, please remember to click like, subscribe, and share with your friends to watch too. Also, I've recently joined Patreon. If you want to support my work, visit the link there. Contribute a coffee of some small amount of money to support my work. Also, I've put down some useful links for components and 3D printers that you can buy through Amazon. If you go through those links, you won't get a price uplift, but it will mean a lot to me because a tiny bit of money will be sent to me by Amazon to support my work. Thanks a lot. Without further ado, let's complete part 3. Part 3 includes drilling holes on the board, engraving your name and dates on the board, gear animation to see how the variable capacitor works, and layout for printing, putting all the parts on surface with the right orientation so it can be printed. We need to draw a rectangle to create a hole just below the coil so we will not impact the Q factor of the coil being too close to the baseboard. So we use the rectangle command in the sketch to draw a rectangle. Next, we need to draw a line in the middle of the rectangle. So when you hit the middle, you will see the triangle, and it will show you that it's the middle. Then we right-click, turn it into a construction line, and then we'll pick a point where we want to have our hole drilled, where the legs of the coil will pass through. So we right-click on there, type the command C to create a circle. Then we need to draw a horizontal line for reference at the middle of the rectangle. And then again right click and turn it into a construction line. Next, press the S key. We'll bring up the sketch menu and press type mirror to select mirror command. Then we'll need to select the circle to be mirrored, both the middle point and the peripherance of the circle, and then select the mirror line, which is the line we just drew, the horizontal line, then click OK. You find the circle on the top is copies down to the bottom, so to maintain symmetry. We are going to extend the horizontal construction line further to the edge of the box. Just draw a line there and right click, select normal construction to turn it into a construction line. Press S key to bring up the sketch menu and then type in rectangle and select center rectangle. Right, because we're going to use it, we can click on the arrow to add it to our menu and click the center rectangle icon. So the nice thing about center rectangle is when you find the center of the line, fix the center of the rectangle there and then you drag it, it will give you a rectangle centered on your line. So we're going to create this for a socket, 4-pin socket, where we will plug in the diode crystal or MOSFET. The size will be 11 millimeter times 2.9 millimeter. If you don't like the position, you can highlight all the sketch and then just move it. Because we are using reference line, anything you move, all the other sketch patterns will move at the same time. So this is the nice things about Fusion 360. They will align and move together. in one group. Then you can move the dimension text to the right place so it won't block the other patterns. Next, we're going to drill a few more holes for the fixed capacitor, the one that will smooth out the audio, remove the high frequency. It's a high frequency filter. So let's pick a point, click the C command, the circle command, pick a point at the center of the circle, drag it to 2.8 millimeter diameter. And then we can draw a second circle which will be used to hook up to the bare wire headphones. If you want bare wire headphones instead of a headphone jack, you can drill this hole here to mount the M3 screw where you can connect your headphone jack, headphone line, the bare wire line. Okay, so again we are going to use the mirror function. Highlight both circles, click S, select the mirror, which is the double triangle, and then select the middle line, and okay, you get the symmetry and replicate it to the two holes down below. So now we've got 4 holes drilled, the coil, 2 holes on the coil, and then the socket for the MOSFET and diode. So now we need to drill a few more holes for the antenna. So let's pick the hole, draw a horizontal line, turn it into a construction line. Let's draw 2 more vertical construction lines so the holes can align with the other holes already there. The second one I'll align with the socket. And then we turn the 2 lines into construction line, right click, normal construction. Then at the cross section of these 3 lines, we can draw our circle and drill the holes for our antennas. The antenna is an M4 screw, so we'll draw the holes of 3.5 millimeter. So 2 circles are drawn. Now we have all the pattern we have. The next thing is to actually drill the holes. To do that, we hold the Shift key and then use the left mouse button, click and select all the holes we want to drill. You notice that you have to click on a part that is not an edge. So between the center and the edge, there's all the white space there. Once you click on that, that part will be selected. Sometimes you have to enlarge your drawing to find that spot. It's a bit difficult for circle because you've got a center there blocking your click. Enlarge it and you'll be fine. And one more circle to go. Okay. So all the patterns have been selected and we can start drilling the holes by right-clicking and select the press pull. On a distance, we select to object and then select to cut. And then we flip the wheel to the bottom. And then we select the bottom of the baseboard. So the holes will cut through to the bottom of the baseboard, like that. Click OK, and the holes are drilled. We can examine it if there are still holes that are not drilled down to the bottom, like these 2 holes on the fixed plate. You see they are not white, that means they haven't been drilled through. Then it's easy, you just highlight them, Shift key, hold the Shift key and highlight the second one, and then right click, press pull. Get the menu up and then do the same thing. Distance to object and then select the back of the baseboard and select cut. And then you will cut through and have the holes you need. Next, we need to drill the holes on the side of the box of the baseboard. So let's turn the wheel to the side. Click on the surface on the side and then click the Sketch Align command on the top. To better align the headphone jack to the two screw holes on the surface, let's draw a line from the center of one of the holes down to the side and make that a construction line. Repeat that for the second hole there. Let's draw a line from the center there and make it a construction line. To make sure the two lines are perpendicular to the base of the board, we can use the constraint here. I use the perpendicular constraint to mark the line with the bottom of the baseboard so it becomes perpendicular. Then continue to use the line command and move my mouse to where I see the triangle. Triangle means middle of the line. I draw the line there from the middle of the two vertical lines. So this is the good point to place our headphone jack. But it may be a bit too high, so I draw a second line and make that parallel with the first line. Then I draw a vertical line at the midpoint of that second horizontal line. Drag it all the way to the bottom. To turn them all into construction lines, I highlight all of them and right-click and select Normal Construction. Then I pick the middle of the second line to draw a circle, which will be my headphone jack. This is 6 mm for a headphone jack. Then I right-click on the circle, press 2 to drill the hole. The last two holes we need to drill is on the other side, so let's flip through it. So we need these two holes to be the antenna hole aligned with the two M4 antenna holes on the top. So repeating what we did for the headphone jack. Just draw two vertical construction lines and a horizontal construction line at the middle of these two lines. Then we can type the C key to draw two 3.5 mm circles and then cut the holes we need. This step is optional. If you want to engrave your name or date on the creation, then you can do this. Select the surface of the baseboard, type the S key to bring up the sketch menu, click on the letter A for text, and then pick the spot where you want to engrave the word. Flip the wheel upside down. I don't know how they design the software. It's always upside down, right? They may have to fix it. But type in the text you want to engrave, and then select the height 5mm is the right size, otherwise it will be too big. You also need to select the fonts. We will need to select it to be Arial black, otherwise it will be too thin and you won't notice it after printing. So that you may need a multiple line because one line may not be long enough. So the second line goes the same way, flip it 180 degrees, upside down, type in the text. Change to 5mm first, type in the text. And Arial black, and OK. So I need the third line now for the dates, so let's repeat it. This step will just give you the symbol on the screen. It won't actually engrave into the box. To engrave it, highlight all 3 lines of text, right-click, press pull, and then select the depth of the engraving. How deep you want to cut through the wood. Minus 0.5 will be too light, minus 1 will be better. So minus 1mm down, cut down into the wood, select cut and OK. That's it. There you have it. This is finished. The entire FM crystal radio design. If you like my video, click like, subscribe, and share with your friends too. Again, if you want to contribute to my work, you can visit my Patreon site to give me a coffee or a small subscription. Even better, if you like to buy electronic components or anything from Amazon, go to Amazon through my links. It will give me some very tiny money back, but it won't increase your price. That will help me a lot to support my work. Thanks again. See you in the next video where I will really create this crystal radio in real life with the links I provided for the components and 3D printers. Thanks again. See you next time.